Hi folks, and welcome back to Math with Captain Rod. The purpose of this video is to demonstrate how to solve a differential equation, a first order differential equation with an initial set of conditions here. So what we're going to do here is we're going to try to solve the equation dy dx equals 9x squared minus 4x plus 5, given the condition that when x is negative 1, y has to be 0. So when solving this, the first derivative is a separable thing. It's the ratio of two differentials. So the first step in solving an equation like this would be to multiply both sides by dx, in which case this is going to read dy equals 9x squared minus 4x plus 5 dx. And the solution of this is some function of y. And that's what we're looking for. What is the function that solves this original equation? And it's solved by integrating both sides. So what I'm going to do here is now we're going to look at integral dy equals integral 9x squared minus 4x plus 5 dx. Now the integral of dy, or this means find the antiderivative of dy, that's just y. Now it's technically y plus a constant, but the other side's going to have a constant too. So you only need to tack one constant on any given line or any given equation. So, and that's because if I tack a c1 here and a c2 on the right, I can move the c1 over, and you're going to have c2 minus c1, which is just some other constant c3. So as we go through here now, and I'm going to just integrate this term by term. So the antiderivative of 9x squared is going to be 9x to the third over 3. That's power rule. Minus 4, all right, antiderivative of x is x squared over 2. And then last term, the antiderivative of 5 dx here is 5x. And here's where I'll go ahead and tack our constant. I'm going to go ahead and clean this up a little bit. I'm going to write this 3x to the third minus 2x squared plus 5x plus c. So what we have now is we have the function that when you differentiate it, we get this. And what we really have is a family of functions because we have this plus c here. This c can be really any value at this point. It could be 1, 2, negative 7, 152,653.602. It can be any number that you can think of to insert for c. So at this point, again, what we have, this is called a family of functions that satisfy this equation. We're looking for a very specific one, and that's where we will look to this condition to find the specific one or find the value of c. So the condition we're given, when x is negative 1, y has to be 0. So I'm going to go ahead and put a 0 here. Now if I put a negative 1 here, this term is going to be minus 3. If we put negative 1 here and square it, that's plus 1, so that term is just going to be a negative 2. If I put a negative 1 here, that's going to be minus 5, and then plus c. So again, this line is coming from putting negative 1 here, here, and here. Now to solve that for c, all we got to do is add these terms to the right. So let's see, 3, 2, and 5, they add to 10. So the function we're looking for, the specific function, is 3x to the third minus 2x squared plus 5x plus 10. That equation should solve the following conditions. 1, when you differentiate it, you should get 9x squared minus 4x plus 5. And if you put in negative 1 for x, you should get 0 out for y. Hope this helps solve these equations, or I hope this video helps demonstrate how to solve first order linear differential equations. Have a great day.